And welcome to Kopernik Observatory. It's great to see you all here this evening. My name is Drew Desker. I'm the director here at Kopernik, and see some brave souls that made it up here on top of the hill in the rain. And I want to welcome those who might be watching on our live stream. By show of hands, who's here for the first time or hasn't been here since their 4th grade trip? Including our speaker. Well, it's great to have you with us here. And who here are members? All right, basically the other half. All right, super. Well, again, I want to welcome especially the newcomers. Kopernik is really a place where we really try to promote lifelong learning. We have a wide range of programs that we offer here, from literally kids as young as 3 years old for what's called Kopernik Kids, through people like us that just like to learn and continue to learn through our entire life. So actually, give me a moment here. I'm going to get out of our presentation here and just go quickly to our website. So our website actually is pretty. We keep it fairly up to date. Usually gets updated a couple times a week, depending on sort of what's going on. We always promote what's coming up next. In our case, this is our program here this evening. But you can see, you go over here to classes and events and programs, go to public events, and public programs, and it'll take you to what's coming up next. Next Friday, Black Friday, is we always do it's our tradition to do black holes on Black Friday. And so Roy Williams is one of our educators, and he'll be talking about black holes. And we actually have a black hole simulator that you'll want to check out. If we go back to our home screen, one of the things that not everybody knows is that the Kopernik Observatory was actually was formed back in the early 1970s by a group of Polish immigrants, people of Polish heritage, that wanted to commemorate Kopernik's 500th birthday. And so part of our bylaws is we're charged with running an astronomical observatory, but we also, part of those bylaws, are to promote Polish culture. And so every year, as long as there's no pandemic going on, the Polish Society has it's called a traditional Polish Christmas Eve dinner called Vigilia. And it's a meatless dinner. It's fish and just sort of standard Polish comfort food, and it's open to the public. So if you're of Polish extraction, even if you're not, but you want to just sort of experience that, go to our website and you can see what's going on there. One of the things that we do here that we don't promote all that much yet is one of the things we actually have we have a weather station here that actually reports on Weather Underground, but we also have a receiver that actually picks up NOAA weather satellites, what they call the APT satellites. These are low Earth orbiting satellites. So if you go to Visitor and you go to Weather, and you look at the Kopernik weather satellites, you'll see that, of course, I've got some crummy images. There's a thing called bias T that didn't get turned on. I'm going to have to talk to my students about that. But if I go back to this, actually, if I go here, if I go down to the archive, NOAA 18, I can look at some pretty neat images. So this was actually taken earlier today, just about 11 o'clock in the afternoon. And this is a combination of infrared and the MCIR. Do you know the Okay, but you can see there's a huge storm system down in the Atlantic, and you can see what we're dealing with right now. But anyway, so there's a lot of neat stuff, a lot of fun stuff on our website, and so we invite you to check that out. And if you're not also on our email distribution list, you can go to the bottom here, and you can get your signed up. For the email distribution list somewhere. Used to be on our front page. I'm going to have to find where that is. Visitor support, contact us. Well, anyway. Oh, get on the mailing list. There it is. It's even right there. You can put your email there, and we'll just, usually, twice a week, we just let you know what's coming up. But again, we really are trying to promote lifelong learning, and not everything we talk about up here is about astronomy. And but actually, one of the things I'm sorry for jumping around here a little bit, just reminded me that we have a YouTube channel, and this YouTube channel has really gotten a lot of use since the pandemic. So back in 2020, we had our Friday night programs all lined up, and then we had to shut down because of the pandemic. And we said, okay, well, we'll just hold off for a couple of weeks until this whole thing blows over, and well, that didn't quite work out, did it? So about in May, we decided, look, we have all these speakers lined up, why don't we work with them? And so we actually had them Zoom into our facility here. We then turned that right around and put it out on a YouTube channel. We now have over 13,000 subscribers. And so again, you can watch, like many are watching this evening, the YouTube program live. But also what's nice about it is that our programs remain on our YouTube channel. So like last week, we actually had Dr. Hunter, who actually is in the house, talk about concussive brain injury. The week before that, we had somebody from the Central New York Lyme Alliance talking about ticks and Lyme disease. And the week before that, we had actually one of the mission scientists on the OSIRIS-REx mission to Bennu talk about the mission, and this was literally 3 weeks after that capsule returns. So there's a lot of great stuff on here. We even do live observing sessions. Appreciate meteor shower we've done. We do also some eclipses, and we've got another eclipse coming up next year, a solar eclipse, and we'll be live streaming that as well. But anyway, you're all here to get educated about El Nino, and we're very fortunate to have a National Weather Service office right here in Broome County, and a great staff. And the thing about it is, there's always somebody up there, right?
Yes.
24 hours a day.
365.
Right. Nobody takes a break from the weather. And Mike Murphy is lead meteorologist up at the National Weather Service, and we're very fortunate to have him with us tonight. So, Mike, it's up to you. I'm going to get you back to your program. And there you go.
Okay. Thank you very much for that introduction, Drew. Appreciate it. And despite what you guys might think, we obviously cannot control the weather. If you look outside tonight, I wouldn't have picked a cloudy, rainy day to come here. But we can try to predict the weather. And so this presentation is going to be, first half is going to be a little bit about the Weather Service, some of the products we issue, the watches, warnings, advisories in the winter coming up. And then second half, the main topic, as Drew mentioned, is going to be about El Nino, the Southern Oscillation, and what that may mean for us for this upcoming winter. So during the first part, like I said, I'm going to go through the Weather Service, introduction, watches, warnings, advisories. Then I'll give a chance for any questions after that part, and then we'll switch topics after that. So as Drew mentioned, we have the Weather Service office right here in Binghamton. We're located up on Airport Road by the airport. And this is my office here. And this is our office here. And this is our mission. We provide weather, water, climate, data, forecast, warnings, and impact-based decision support for the protection of life and property and to enhance the national economy, because we're actually part of the Department of Commerce. So we have our office here in Binghamton, but then we also have the office in Buffalo, Burlington, Albany, New York City that cover New York State, and we have 122 offices across the entire country, Alaska, and out in the Pacific Islands as well. So our forecast area at the Weather Service in Binghamton, we cover all the way up north from Oneida County down to Luzerne County, Scranton, Wilkes-Barre, Utica up north. We go over to Steuben County. We include Syracuse. We go down to Monticello and the Catskills. So we cover a pretty big area. And yeah, let's get right into it. So we're heading into winter here. So like I said, we're going to go through some of the products and advisories, warnings we issue. A lot of you guys are probably familiar with this, but if not, we're going to go through the criteria. So as far as winter weather advisory, we'll be issuing this when there's high confidence and more than 4 inches of snow for New York, and then slightly less, 3 inches of snow for northeastern Pennsylvania. And again, that's high confidence, and we could also issue it for a combination of snow and ice, freezing rain and sleet, all of that too. And then over here, with the winter storm watches and warnings, the criteria is going to be 7 inches of snow for New York and 6 inches in Pennsylvania. The watch confidence is 50%, so lower confidence for a watch, and then 80% or more for a warning. So if we get closer into the event, we get more confidence. That's where you're going to see the winter storm warnings coming out. And again, we take into account, it's generally 7 inches of snow, but we take into account impacts to the community as well. If there's any sleet or freezing rain mixing in too, that can make it worse, obviously, out there. So we'll probably be seeing these headlines coming out pretty soon, heading into the next month. And then, of course, we can get blizzards too. These are pretty rare for our area, but they can happen. And the official definition of blizzards is you have to have 35 mile per hour winds, either sustained or frequent gust, obviously blowing and drifting snow, visibility less than a quarter mile, and it has to be for 3 consecutive hours. So that's what we look for. So if you see a blizzard warning out, that's what we're expecting to happen. And yeah, it is true, we don't necessarily need falling snow for it to be a blizzard, but a lot of these ground blizzards happen out in the Great Plains where it's flat and there's no trees. We don't really get ground blizzards around here, or at least I haven't seen one yet, but maybe someday. So just some examples. If you all have lived here, you've seen how much snow we can get. So back in March 2017, we had about 28.8 inches of snow, and it even went higher than that after this photo was taken. We had 5 inches per hour snowfall rates. We broke snowfall records at Binghamton, Utica, and the Avoca or Scranton-Wilkes-Barre area. Near the end of this storm, the winds picked up, and it was near blizzard conditions, but not officially blizzard conditions with this one. So this was just what we call a nor'easter, significant snowstorm. But yeah, this was back in March 2017, and this impacted basically the whole area. But you can see anybody in dark red here got between 18 to 30 inches of snow from Syracuse, Binghamton, and then the peak of the storm was over Otsego County where they got up to 36 inches of snow. Yeah, we got quite a bit here in Broome County. The whole county got 20 to 35 inches. And as is typically the case, the snow usually cuts off quickly. We get a lot more snow here in Binghamton compared to over by Elmira and Steuben County usually, so they got less over that way. So switching gears a little bit from that storm, we're going to talk about lake effect snow now. We do get lake effect snow, obviously, in central New York. We can get a little bit of lake effect snow down here in Binghamton, although it's more rare. It usually impacts to the north up towards Syracuse, Utica, Rome, and we'll show that on the map coming up next. But lake effect snow, the general mechanisms of that, just a quick overview, is just when you have the really cold air going over the warm water of the lake, that creates instability, and it allows clouds and narrow bands of heavy snow to form downwind of the lakes. So that's just generally how it happens. And if you get a longer fetch, that's when you're going to get heavier lake effect snow. So for Syracuse itself, we look for a wind direction between 290 to 305 degrees, and that brings the fetch all the way from Lake Superior, Lake Huron, Georgian Bay, Ontario, right into Syracuse. So if you're up that way or you know somebody up that way, you look for that 300-degree wind direction of cold air over the lakes, and that's where you get the most snow. For us, the wind direction is more like 310 to 330 degrees, and that just means like northwesterly. That's when we get lake effect snow down here. And we'll show that next after this one. So this is from 2 years ago, November. This is just an example of how that lake effect snow, a significant event, can occur. This one affected areas further north. We didn't get much here, but out towards Buffalo, they had 81 inches. This looks like it was just south of Buffalo. This is over a 5-day period in November 2022. So these are the lake effect hotspots. Southwestern New York near Buffalo, and then off Lake Ontario it comes across Oswego County, northern Oneida County, and then up on the Tug Hill Plateau here, the higher elevations, which they got 50 inches in this event up there. But you can see how localized it is. So we got 0 around here, or a trace of snow.
That snow would be over my head.
Yes. So here's an example of a rare lake effect event that actually did impact Broome County, and we got a lot of snow from this one. I don't know if you guys remember this one back in 2016. Anybody? Yeah. So this is November, so a lot different from what the weather we've been experiencing lately. We haven't gotten any snow here lately, but back in November 2016, just a couple days down the road here, 19th through 22nd, we picked up over 15 inches of snow in Binghamton. I think the airport had 22 inches up there. And this was a very rare scenario where we had a coastal low here over Maine and New England, and it was wrapping around Atlantic moisture all the way up into Canada, then over Lake Ontario. And that's why the lake effect snow spread further south and east than it typically would in most events. So this was a big one. And I guess I won't show the radar loop right now, but this is an image of the radar from that day. So these bands were just forming off of Ontario, and the Finger Lakes can get involved sometimes too and increase the lake effect snow for our area as well. And that was happening in this storm. So this just continued like this for 2 to 3 days straight. And yeah, the airport, it got 27.6 inches of snow up at the airport, but even down here in Lake Vestal, 16 to 20 inches down here, which is very rare. We usually don't get that much lake effect snow here. So switching gears a little bit again, so we talked about lake effect snow. Then we have another winter hazard called snow squalls too. Anybody here heard of snow squalls? Okay, very good, glad. So these can be very dangerous. These are quick hitting, heavy snow showers with wind that come through, and they only drop about an inch of snow. So if you're at work or at school or in your house, it's no big deal. You look out the window, oh, we got an inch of snow. But the problem comes if you're driving on the highways. That's where these can be very dangerous, if you're on the interstates especially. It brings whiteout conditions really quick. That wind and the snow reduces visibility to less than a quarter mile, and the road becomes icy and snow covered like in an instant. So we issued these warnings to try to help people safely exit the highways and wait out until the snow squall moves past. And these are a pretty new product. We started these snow squall warnings in about 2018, I believe it was. So yeah, we've been doing it for about 5 years now. And these will actually, if it's dangerous enough, we have the ability to set off your cell phones with the WIA alerts for these, so just to make sure people get it when they're on the highways traveling. And yeah, this is an example of what it looks like out there and why it can be so dangerous. It's sunny a day, and then all of a sudden you run into this snow squall. Boom, visibility drops to almost nothing. The roads turn icy and snow covered immediately. And yeah, and then you can't see the cars, and just you get pile-up situations.
I think that white car is lucky. Never mind.
So these can be very dangerous, and it's something to look out. Probably one of the worst winter hazards we actually have around here, because this causes the most accidents and the most deaths during the winter, believe it or not. So then, on top of all those winter hazards we talked about, we have ice too. So just throwing this on top here, we also can get ice in our area, and we issue winter weather advisories anytime we're expecting even 1/100th of an inch of freezing rain, because that can, as soon as you get just even a light glaze of ice, that can obviously turn the roads very dangerous, very slippery. And then we issue the ice storm warnings when we're expecting a 1/2 inch or more of ice accretion from freezing rain, not sleet. And once you get to the 1/2 inch of freezing rain, that's when you can start to get significant impacts from the trees, power lines coming down, power outages, all that stuff on top of the dangerous travel conditions as well. An example of this is back at the ice storm of 1998. It didn't affect this area, but it was more up towards the St. Lawrence River Valley here of northern New York and parts of southern Canada. This was an incredible ice storm. It dropped up to 3 inches or more of freezing rain, ice from freezing rain, and this is what it did. All the trees came down up there. Power lines, transmission lines came down. It was a disaster up there, and all these other impacts as well were here. But this was a really bad case of what can happen when you get those ice storms that sit over the area for days and days. And this hasn't happened recently in our area, but just a reminder again, this is not that far away, so this can happen here. Something we need to keep in the back of our minds and be prepared for. On top of that, we also have very cold air that comes down into our area. We get Arctic outbreaks of air, and when we have these situations, we issue wind chill advisories and warnings. So wind chill advisories are for -15 wind chills, and warnings are -25. So in these situations, it's just good to be prepared if you're traveling. Don't take these lightly, because you might think, I'm just going to be driving in my car, I'll be fine. But if you get stranded out there, you got to be prepared, because -25 can really cause impacts quickly if you're out there in your car and you get broken down. So bring warm clothing with you, be prepared, bring blankets in your car, all that if you're traveling when it's really cold out like this. Okay, and then yeah, we have the best weather in the winter around here. On top of all that, this is usually our season where we get the highest winds too. Winds start picking up in the fall, winter, and it lasts into the spring through about March. And this is when you'll see we issue our wind advisories for gusts of 46 to 57 miles per hour. We issue high wind warnings where we're expecting gusts over 58 miles per hour or sustained winds of 40 plus. So watch out for that. If you see high wind warnings, that means there could be damage, power outages, things like that. Wind advisories would usually mean like scattered power outages and maybe some minor tree damage, things being blown around like that. Okay, so we talked about all the products that we issue in the winter. Now I'm going to show you where to find them. How many people have visited weather.gov? Go to the website. Oh, excellent. Great audience. So you guys, I'll go through this pretty quickly then. But yeah, you go to weather.gov. You can click on your locations. And then it takes us to the local page here. And this is where you would see any of the watches, warnings, or advisories issued county by county over the area. And then down below here, I'm not sure if you guys have used this or not, but there's a lot of different links down here. We got winter weather, the snowflake icon, aptly enough. Then we have hazardous weather briefings available, radar, satellites on here, forecast discussion, graphical weather hazards. It's all there, so feel free to explore, check out all the products we issue. And we'll go through a couple of them now pretty quickly. So this is the winter page. This is where you're going to want to go throughout the winter months coming up to see how much snow we're forecasting. And we give more information too. We have our most likely forecast over here, but then also there's uncertainty, obviously. So we give you the range of what could happen. So there's a 10% chance we only get 5 inches of snow in this example, but there's also a 10% chance we get 19 inches in Binghamton. But our most likely forecast is 8 to 12. So it gives you that range. And the tighter that range is, the more confidence we have in the forecast. So this is a pretty low confidence forecast. We're saying it could range anywhere from 5 to 19, expecting 8 to 12. That's a big range. But if we have more confidence, it might be more like 10 to 18, and we're expecting like 12 to 15. So as we get closer and we get more confidence, that range decreases in what we're expecting to happen. And then there's also, if you need to know specific thresholds, like I don't want to drive if there's more than 4 inches of snow, we have the exceedance graphics too. You can say, what's the chance of getting, in this case, more than 6 inches of snow from Binghamton? 16%. Oh, it's not too bad. Further north, it's higher. We have all the options depending on what your personal thresholds might be. We have that in table form too for any locations. You can look that up. Same information. Another product we have is the graphical hazardous weather outlook, and this is more of just like a planning tool. You can see, there's going to be strong winds on Saturday, or there's going to be frost and freeze on Monday, and we have snow and sleet and ice down here, which changes with the season. And it will be the same thing, will light up on what kind of impact we might be seeing. So, limited, elevated, significant, or extreme based on the color. So it's a quick way to just look and say, there's going to be bad weather coming up on whatever days, and you can dig further into it after that. And more tools here that we have available, the Winter Storm Severity Index. This is kind of the same thing as the graphical hazards, but for the entire country. So this might be a good one for traveling if you're driving out to the west or something, or depending on where it is. This shows you where there's going to be high and extreme impacts due to winter weather, major and extreme impacts due to winter weather, or moderate, whatever your thresholds are, but it shows you what is expected to happen. And then there's different factors that go into it too, which you can break down. So again, it depends. If you just want to know, is it going to be significant winter weather? That's all you need to know. I'm not going to travel. You can stop there. But if you want to know, hey, is it going to be snow? Is it going to be heavy wet snow, blowing snow, ground blizzard, flash freeze, ice accumulation? We have all that for you, so we break it down. So yeah, like in this example, for like Rochester, you can see snow amount is causing the most problem, but there is some other issues, snow load, blowing snow, affecting them. But again, you can just look at the overview. We got major impacts from winter weather in Rochester on Wednesday. Probably not going to want to go there, or I'm going to delay my travel. And then we have even another tool for you too. This is the probabilistic winter storm severity index. So this gives you more probabilities if you say, what's the chance I'm going to get a moderate impact or a major impact? And this one goes out 7 days. So this is even further. You can look, this is more of a planning tool, 5, 6, 7 days out. And again, if this is an example, but this will be over our area eventually, inevitably, coming up. So again, you can say, well, I don't care about minor impacts. I care about major impacts. You can set it to major and say, what's the likelihood of that happening? And it will show the likelihood of that happening. So, and all these links are on our webpage under the winter tab if you want to use these tools. So, okay, that's the overview of the Weather Service, the products, all the winter stuff. Is there any questions at this time before we move on to the next part?
Anything on the chat? Nope. I think we're good.
Okay. Oh, there's a question.
Actually, hold on a second. Yep. Get the mic turned down so get our mic turned down so that the live stream people can hear.
Hi. So, did I see correct that watches and warnings have different definitions in different parts of the state or country?
Yes, they do. It's based on climatology of how much snowfall and winter weather that the area typically sees. So like over the southern U.S., it would be lower, like 2 inches, compared to we need 6 or 7 inches up here. So, yeah, it's based on impacts. Yep.
All right, I guess.
Oh.
No, I'm sorry.
Another question.
I'm just question blind here, I guess.
When we hear or see the weather forecast on the television, what are they talking about? At the airport? Are they talking downtown?
As far as like temperatures go, you mean, or
Anything.
anything? I can't really answer that because, Nicole can answer that. 'Cause
So yeah, when you see the temperature for Binghamton, it's the airport pretty much. Yeah, we're taking you see current temperatures and stuff. It's what they're currently seeing. Usually updates once every hour. So yeah.
She's a meteorologist for Fox 40. Okay, any other questions?
All right, let's press on.
Okay, so now we're going to move on to part 2 here, which is the main show here, talking about the El Niño, moderate to strong El Niño, and how that could potentially impact our winter outlook and winter for this upcoming season. So just starting off with the basics here, this is a cool diagram I found. So this is when we're in NSO neutral out in the Pacific, this is what we see. We just have weaker trade winds out here. And again, we're talking about South America along the equator here. Here's Mexico. So out in the tropical Pacific, we have weak trade winds during the neutral conditions. And this pushes some of the warm water over here towards like Australia, Indonesia, and that's where you get convection and thunderstorms over in that area. But this year, we are seeing that El Niño. It's well established out there. It's getting stronger. And all that means is that we have warmer than average water temperatures developing off the coast of South America, and it's being pushed by the weaker trade winds over here. So it's not upwelling as much, and the water's staying warmer in the central Pacific, and that's creating more convection and thunderstorms activity more towards like the date line near 180 west. So that's the main difference is just the water temperature. Again, it's definitely averaging warmer than average this year. We'll take a more in-depth look here. This diagram shows this kind of the same thing, the water temperatures compared to average out here. But this shows the depth too. So this goes down, 400, 600 feet. So we have that warm water along the South American coast, mostly in the upper layer, and then out in the central Pacific, it's deeper. It's down to 400 feet. So that's a lot of extra energy out there. It's a lot more energy with the warmer ocean temperatures out there. And let's see, this goes from September through October 30th. So you can see how the water kind of shifts to the west in general with the ocean currents out there. But we have all this red on here. This is the El Niño. This is the warmer than average water. It's out there. It's well established, and it's deep. It's down to 600 feet in some parts of the ocean. So with that in mind, we definitely have current state El Niño. El Niño advisory is in effect. As I mentioned, the equatorial sea surface temperatures are above average out there in the tropical Pacific where we look for ENSO. Tropical Pacific anomalies are consistent with El Niño. El Niño is already there, and it's going to continue likely through the spring, but it kind of fades off as we get towards May and June, which I'll show later on. So by the time we get to late spring, the percentage chance for El Niño dips down to 62%. Right now it's like 100%. Another way to look at it, this one's a little bit tricky, but the time goes down from December 22 to where we are now, November 2023, and this is the longitude. So over here, this is like the South American coast, this is the Central Pacific, and this is along the equator out there. And this is over towards like Indonesia over here. So the water, we had La Nina back in 2022 into early 2023. Then we started to see warm water developing along the South American coast, which is what always happens when El Nino begins. And now it's been spreading out to the west more across all the Pacific. And here we are right now down here. So we have warm water across most of the tropical Pacific. Yeah. And then as scientists, we like to break it down even further and look at things in different ways. So we look at the plan view of the ocean. Over here, we look at different regions. So we have Niño region 1 and 2, that's right by South America. Niño region 3 is more off the South American coast in this red box. Sorry. And we have Niño region 4 in the yellow box. And then we combine two regions to make it Niño 3.4. So, and that's actually the one that's looked at the most. That's considered the most critical one to look at, is that 3.4 region out there. But we do look at all of them, and they're showing some differences here. The warm water peaks initially along the South American coast early, back in the summer here, and then it's actually been tailing off the warm water a little bit. This is the anomaly, the temperature anomaly. Region 3 is kind of leveling off now. Region 3.4 is still increasing, but getting ready to level off. And then kind of the same thing, Region 4. So overall, it looks like El Niño might be peaking as far as the intensity of the ocean temperature anomalies. It's getting close, but we'll talk about that a little bit more. There's some uncertainty in that still. But yeah, the anomalies are strong. So we have 1.8 C in the critical 3.4 region that we look at. And that is above the official definition of a strong El Niño, which is 1.5. And this is looking at the entire global sea surface temperature anomalies out here, October 15th through November 11th. And yeah, here's our El Niño right here. This big orange red area above average sea surface temperatures, 1 to 3 degrees, all expanding out to the date line here. And the thing is, we have a lot of warm water across many areas this year, so we're not sure how that's gonna influence other factors too. We have warm water near Japan and north up here, a little bit south of Alaska, and then also a lot of the eastern Atlantic is warm. Recently it's cooled off near the east coast, so a lot of different factors, but the El Niño is one of the main things we can predict a few months in advance, and that helps us to predict the winter weather coming up. So how has that water temperature anomaly changed in the past few weeks? This is November 8th minus October 11th, so about a month. What happened over that month? We saw some differences, some cooler water developing in pockets here, but also some warmer water developing in the Central Pacific. So overall, not much change. I think it's kind of been steady, but minor changes. And then I wanted to show this too, looking further back in time. You know, how does this event compare to previous El Niño events? And if you look at the basin-wide upper ocean heat content anomalies, this can give us an idea. So here's our current El Niño. Well, first of all, we've had La Nina the past couple years, and then here we go, it developed. We got those warm anomalies here starting to increase. But you can see it's not quite as strong. We had one back in 2019, and then a pretty significant El Niño back in 2015 and 2016. That one was very strong. But you can see the pattern, it flips around every couple years. So nothing too out of the unusual with this El Niño, at least right now. And oh yeah, this is the top chart here is also something we should look at. The Oceanic Niño Index probably gives an even a better view of how strong that 2015-2016 El Niño was. That was up to 2.5. So that was a really strong one. And if you remember that year, we hardly got any snow here at all. That yeah, that was one of the least snowy winters. I think the least snowy winter on record here. So that when you get really strong El Niños, that can cut down on our snow here. But again, right now we're at about 1.5. So we have to see if it gets any stronger. But at this point, it's probably peaking right now is what it looks like. And then, so once we have those sea surface temperature anomalies, that obviously can impact the atmosphere, which I kind of hinted at a little bit. But we have more where we have these negative outgoing long-range radiation anomalies. That's where we have more enhanced convection precipitation. So we have thunderstorms developing over here, which is different than the neutral years, and that's how it impacts this whole atmosphere. It's kind of a chain reaction from that. Let's see. We also look at winds at about 5,000 feet, and these anomalies are westerly over the Pacific right now. Hard to see the arrows, but the anomalies are, 3 to 6 knots. So we have westerly anomalies over here, and that also impacts the convection, and that then down the road impacts our weather patterns. And okay, and then looking back even further since 1950, just wanted to show again, these patterns are typical. We've had strong El Niños. Well, here's ours right now on the way up. I guess the one in 2019 was pretty weak. But then, yeah, this is a major one, 2015, 2016, 2009, 2010. We had a decent El Niño 2002, 2003, which was actually a snowy winter around here. Got quite a bit of snow that year. And then one of the major El Niños that people look back is 1997, 98. That was a very strong one too. But I think, yeah, 2015, 2016 was stronger than that one as far as the oceanic anomalies. And yeah, going back, we had one 87, 88, 1983, 73, all the way back. So yeah, this one so far is not too atypical. But again, we'll have to see exactly how strong it gets. And some signs are pointing it to a kind of leveling off now. So kind of summarizing, yeah, the current El Niño is officially strong because it did reach that 1.5 degree Celsius threshold that we look for. El Niño is definitely going to continue through the winter. There's no doubt about that at this point. And then it is going to kind of tail off the percentages heading into the spring here, getting down to like 62%, like I said, by May, June, July. And yeah, this is kind of out. We just reached that threshold, so there was a chance, but now it looks like we definitely reached that strong El Niño threshold. But just because we're at 1.5 doesn't mean it's going to be a repeat of 2015, 2016. And this gives another example. Yeah, here we are, the purple line. You know, we're getting up just above 1.5, but you can see there have been El Niños since 1950 that are stronger. This doesn't give the year, but you can see there's 1, 2, 3, about 5 El Niños were stronger than we are right now. So the question is this it? Are we going to just start going down? Or are we going to see a secondary peak and it go up and start to rival some of these strongest El Niños on record? Right now, the data is pointing to it probably peaking, but we'll show more of that next. Yeah, so these are the models we look at. And this helps us, but there is quite a spread. So here we are right here. You observed right around 1.5, 1.6. And some of the dynamical models are saying it's going to just inch up around 2 for the anomalies and start to go down. Meanwhile, the statistical models we look at are showing that this is it. It's going to go right down. Same thing with the CPC control model. So there's differences, and we don't know yet. Is this it, or is it going to be a secondary peak? And that could have a major impact on what we see this winter. And there's still uncertainty in that, unfortunately. And I want to show this model too. This is a CFS V2 model, and this is one of them that thinks, hey, we peaked. This is it. Here we are at 1.6 or so, and this is it. It's going to go right down a weekend after this. And this shows, this is December, January, February, March. So, Niño's definitely there into the spring. And then you can see it actually starts, this particular model wants to bring it back to a La Niña by the summer. But we're not, it's way out there. We don't know about that yet. So, but yeah, this one was interesting because it showed it peaking right now. So, and yes, I'll go through this part quickly. But yeah, I mean, the El Niño definitely could have atmospheric impacts. And we haven't seen anything too significant yet from the El Niño. These are the 500 millibar height anomalies, and that's at about 20,000 feet up. So we look at these, and back in September, we had just some weak troughing over the eastern U.S., actually through most of September, and then it got stronger in October. Cooler weather, wetter weather developed, and then here we are recently. We got into kind of like a westerly zonal flow, so nothing too significant has shown up yet as far as El Nino patterns impacting the northeast U.S. at least. And this is the jet stream anomalies, or no, not the anomalies. This is the jet stream wind speed at 200 millibars, which is like 40,000 feet up, so way up there. And the one thing of note is the split jet structure showing up in the Pacific. So this is typical of an El Nino. The northern jet, and especially the southern jet stream, is very active across the southern U.S., and it's just getting stronger as we get into November here. And that fits very nicely with the typical model of what El Nino brings for wintertime patterns to the weather. So yeah, the one thing we definitely look for is this extended Pacific jet, and it's out there already, and it's just going to get stronger. So we're pretty confident in that. That's going to bring wet weather, cooler weather, because with the clouds and the rain, that's going to keep temperatures down across the south. But it doesn't mean they're going to get snow. They're just going to get a lot of rain down there in cloudy, cool conditions across anywhere from the southwest right to Texas, Florida, Carolinas. And then in typical El Nino patterns, which we think is going to set up this year, we have more high pressure and warm conditions up into Alaska, Pacific Northwest. And then we see that polar jet stream diving down on the backside of that. And then the question is this polar jet going to be up across like Maine and Quebec up here, or is it going to dip down into the Great Lakes and be over our area? And that's the main question. That's a tough one to say. And more than likely, it's going to kind of fluctuate. So we'll probably get cold outbreaks, then we'll shift back north. So, but yeah, we're kind of in our area. El Nino, I mean, it's not a really strong signal unless we get to that strong El Nino. And that's when we see the warm, very low snow winters. When we get the very strong El Ninos, which this one, again, it's getting close. But so we dug further in. We dug into each individual year that had strong El Ninos in the past, because we like to look at the past to see what might happen in the future. So these are what we call analog years. Other years with strong El Ninos, we looked at December, January, February. So other strong El Nino events, you can see the years listed here. There's that 2015, 2016 I talked about a lot. But you can see, just because we have a strong El Nino doesn't mean we're going to see really hot, really warm temperatures this winter. The correlation is not that strong, unfortunately. I wish it was strong. I wish I could tell you what's going to happen this year. But for our area, it's a mixed correlation, really. Some of these strong El Nino winters were warm, 2 to 4 degrees above average, 1998, 2015, 2016, 82, 83. And yet other were cooler than average, 2 degrees below, 2009, 10, 65, 66, 57, 58. So it was a mixture. And the weaker the El Nino is, if it's only moderate, so if this is the peak as far as the ocean temperatures and it starts to go back down, it's going to lean towards a colder winter. Because you can see more years with that moderate had that green and blue shade indicating some really cold winters, like 2002, 2003, and all these other ones up here. So we're watching that oceanic Niño index to see if it's peaking at 1.6 or if it's going to start going back down. That's probably going to be the key to this winter. Precipitation's even more of a low correlation for El Nino. It just depends on exactly that storm track, because we have storms going up across the southern U.S. where there's high confidence in above average precipitation, and then it depends if they turn the corner up the east coast or if they go out to sea. And yeah, when you put it all together, it yields mixed results for precipitation, which I'll show in the official outlooks coming up. Even more data, yay. So this is just another way to look at it. We looked at 29 El Ninos here. And so this is like the number of winters were drier or wetter. For our area, when you look at the actual number out of 29, there was more dry. But this included all El Ninos from the weak to the strong. So there was about 20 out of 29 were at least drier than average. And then cooler, it was almost split, like 15, 16. So again, the signal's not that strong for our area. I'll go through this pretty quick, but this is just more of an analysis on the analog years on a month-by-month basis for these El Nino winters we looked at. So December ended up being warmer in the analog years and near average precipitation. January was about half a degree above average, near average precipitation. And again, this is for the previous El Nino winters we looked at, which are listed up here. February turned colder in these El Nino winters, so maybe that could see that again this year. It was about 1 degree colder than average. Precipitation, near average. Again, no strong signal for precipitation. There was a strong signal for a warm March, so we can all hope for that. Maybe it'll warm up by March quickly. So yeah, there was the analog year showed a good 2 to 3 degrees above average for March and drier conditions. So maybe we'll transition right into a nice spring. And then putting all 3 months together for the winter, not much of a signal, really. I mean, 0.5 degree above average temperatures. Precip was a little bit more when you combined all 3 months, 0.5 inch above average. For January, February, March, it was pretty much the same. Just throwing this in here, we also have long-range computer model guidance we look at too, helps us for the winter outlook. So we do use a lot of different tools to make the official outlook, which is coming up next. But yeah, I mean, the computer models are agreeing with this El Nino scenario. They're showing about 0.5 degree above average for temperatures, just like the analog years were showing. So I think we have higher than average confidence in the winter outlook this year, that we're going to see near to slightly above average temperatures. Precipitation, again, this model in particular was showing above average precip slightly, but a lot of it's going to be down here over the East Coast, and then it just depends, or the Southeast U.S., excuse me, and it just depends if it turns up the East Coast or not. So we're going to be kind of on the gradient of precipitation this winter. So putting it all together, so this is the Climate Prediction Center, NOAA Climate Prediction Center. They put all that stuff together, the analog years, previous El Ninos, what happened during those, the forecast models that go out through the winter, and they look at trends as well, recent trends. And what they're saying is, it looks like we're going to see above average temperatures in December. They're favored at least, so 40 to 50% chance for above average temperatures. And then here's, no strong signal for precipitation, so it could be a below, near, or above average precipitation in our area, equal chances. But again, pretty good signal for above average precip down here in the southeast. And then looking at the entire winter, December, January, and February combined, they are favoring, the models are showing, favored above average temperatures, around 45%, which I'll break that down further in the next slide. Look at this precipitation gradient though. This is a tough one. Definitely very high chances for above average precipitation down here, Louisiana to the Carolinas. And again, does this turn up and affect us, or does it stay off the East Coast? And that's uncertainty, but right now the Climate Prediction Center is saying that they're going to go off the East Coast more. We should see near average precipitation this winter. And just so you understand it more, it's broken down, these outlooks are broken down into a 3-category tertile. And so what we're saying when we say 42 or 45% above average temperatures, we're saying there's a 75% chance for near to above average temperatures and only a 25% chance for below average temperatures this winter. So definitely favoring that above average temperature or area, but doesn't necessarily say how much. So as far as how much, they have another product, kind of experimental here, but this is only indicating about 1 degree Fahrenheit above average temperatures for December, January, and February. So even though the odds are favoring above average temperatures, it might only be 0.5 degree or 1 degree above average, which is what the analog years showed too. So, the average temperature in January, the high is like 25 degrees here. So if it's 26, are you going to say, wow, it was warm today? So it might technically end up being above average temperatures, but doesn't mean we're not going to see winter. Doesn't mean we're not going to see snow and cold too. So just don't let that fool you. Yeah, when we round out the winter, it was 0.6 above average, but that's going to feel pretty cold around here still. And there's the precip again. Nothing really interesting with the precip as far as the official outlook. They're just saying we're probably going to end up near our average precipitation, which is around 2 to 3 inches each month for a total of 7.5. With probably more East Coast storms down here along the coast and more precipitation over there. So now we're going to get into the weeds a little bit more even and talk more about snow. So we actually went back and took the data and looked at what kind of snow anomalies we had since 1950 to 2009 during the 10 strongest El Nino events. And for our area, right here in Binghamton, we are around 4 inches below average snow. So the El Nino, the strong El Nino winters did, when you put them all together, did show a little bit below average snowfall, about 4 or 5 inches for our area. So that could be what we expect. But again, it was up and down. Some years had more, some years had a lot less. So that was the average at least. And yeah, this shows just kind of the same thing. There's another database here. We're in the yellow technically, so 75 to 95% of average snowfall is probably where we're going to end up. So we average at the airport 87 inches, so we'll look at that coming up next. But anywhere around 75 to 80 probably. So maybe just a little bit below average, but the higher elevations are kind of showing near average. So that's interesting signal there, especially here and here. So those areas could actually be near average snowfall. Here's our average snowfall, as I mentioned, just in case you were wondering. Yeah, I mean, we're around 75 to 100 generally in our area, depending on elevation. About 87 at the airport. And actually, down in the valley, we probably only average about 60. So definitely lower down in the valley. Okay, so yeah, I ran through the numbers for these El Nino years, month by month basis. Here's the averages. So we're already falling behind. November, we don't have any snow, hardly any snow. I guess we got a little bit, maybe an inch so far up at the airport. These numbers are for the airport. And then we're not looking at too much more snow coming at this point in the forecast, but we'll see towards the end of the month maybe. December, we averaged around 14, 21. So the average for the season during these El Nino winters of the past was 75 inches, like I mentioned. And our typical mean for average for all the winters is 87, so a little bit below, 10 inches below at the airport. And 8 out of 10 years had below average snowfall, though, and 2 had significantly below. And only 2 had above average snowfall. So I guess if you had to pin me down and say we're going to get above or below, I'd say probably below average snowfall, somewhere in this 70 to 80 inch range, probably. But we'll see what happens. And the data was skewed by 2015 and 2016 because there was only 32 inches of snow that year. That was incredibly low snowfall. So if they take that as an outlier, these numbers would be even a little higher, but still below average probably. And yeah, only 1 year had 108 inches. This is a pretty good snowfall. So the chances of seeing a lot of snow this year are definitely dwindling, probably near to below average. So to summarize it all up here, last slide, yeah, it's still going to be winter. Maybe we're going to be a half a degree below average, or above average for temperatures, but we're still going to have winter. Again, above average temperatures are slightly favored over our area due to the likelihood of a stronger El Nino. If that El Nino continues to get stronger, that would lean towards warmer temperatures and less snowfall like 2015, 2016. If it levels off, we'll have to watch that. It could be closer to average snowfall and temperatures. Precipitation is going to probably be near average. There's no strong signal for that. That strong El Nino has developed now officially recently. And like I mentioned, below average snowfall is the most likely outcome, but not the only one. There were still a couple years that got high snowfall during El Nino winter, so could happen this year too. And there could be more wintry mixed freezing rain ice events, unfortunately, too. So that is all. Thank you for your time. Thank you for listening, and I'll take any more questions.
All right, do we have any questions here I know we got some in the chat, but any, actually I have one.
Yes.
As the Earth is sort of warming up, this global warming piece, and you're starting to see, as you're getting higher and higher in latitude, the temperatures seem to be generally rising. Mm-hmm. Has there been any observable shift in El Nino in either in its width or that maybe growing above the getting? It seems like El Nino basically is down around the equator, right?
Yeah.
And I'm wondering, is it widening at all, or is it hard to say?
It's a good question. Also a difficult one to answer, but good question. Yeah, I think if I remember correctly, they're shifting because right now, if you took the water temperature from like 1900 to 1950, every year would be an El Nino. The water temperature is above average, like everywhere compared to that. So they are shifting the definition of El Nino with, I believe, the last 30 years of ocean temperature data. So that's based off like the 1990 to 2020 ocean data. So Yeah, it depends on your definition of average ocean temperatures. 'Cause it is shifting. Yeah, the ocean's getting warmer, so they have to change the definition.
I got another question here in the house.
With the sun becoming active right now,
Mhm.
every 11 years it becomes active and then it cools down or slows down. So how does that affect our weather?
I can't say I know too much about that. I've heard a little bit on that. Yeah, I think when there's more sunspots, that I don't know the science behind it really, but I know that it can cause more what we call high latitude blocking. So high pressures will set up more over Greenland. We didn't talk about that today, but that's called the negative NAO. Can develop more often when we see that, and when we get that, that causes colder temperatures, more snow here in the winter, and just the storms kind of stall over our area more. They don't move as fast. That can happen. But
When you were showing the graphs of the El Nino, it seemed like I was sort of looking for some kind of a cyclical pattern along the lines. I mean, like this sunspot cycle typically 11-year cycle.
Yep.
And I really wasn't seeing that because sometimes you get like these multiple bumps right next to each other, and then it'd be quiet
Yeah.
for a while.
And we don't exactly know why El Nino or La Nina develops every year, or when or why. We don't know exactly why, but yeah, the models can kind of predict it, usually 6 to 12 months in advance, but they have a hard time in the spring. Like I showed in that one graph, La Nina, it was predicting La Nina for next June, but I wouldn't take that. I wouldn't count on that for sure, because the models have a hard time in the spring predicting El Nino or La Nina, but otherwise they can do pretty good once you get into the summer and fall for 6 to 9 months out.
All right. I think we had a question or so from the chat. Hold on here.
Yes, and what I would call a multiple choice question. So
Okay.
here we go. So from Peter, he asks, when he's done with El Nino, similar to the previous question we had earlier in the audience, 50% chance of rain for ZIP 13827. Could that mean 100% chance for southern half of the area and 0% for the northern half? 2, 50% chance for the entire area? 3, 50% for at least one random location? Or 4, 50% for some particular designated location?
Oh, what a multiple choice question. I don't remember all the choices, but basically it kind of depends on the scenario, at least the way I look at it as a meteorologist. I would say like during the summertime, when we're expecting convective showers and thunderstorms to pop up, it'd be more of like 50% coverage of that area is expected to see rain. And then in the wintertime, where we are now, where you see stratiform precipitation coming through, I interpret that to be more of like there's a 50% chance to see at least 1/100 of an inch of rain in that forecast area too. But basically, yeah, like maybe the rain will miss us in the winter, but the summer it's more like pop-up convection. So it kind of changes by the season, I think, the definition I use for probability of precipitation.
All right. Is there any other questions here in the house? Otherwise, Michael, thank you so much for your time and expertise. Personally, I'm looking forward to not having to plow the parking lot as often.
Yeah, we'll see.
I'll hold you to that.
Yeah.
So, but anyway, I want to thank you all for. Actually, we do have another question. Hold on, I take it back.
I just wonder, in forecasting the rest of the winter, if we had a large snowstorm through a large swath of the northern U.S., would you factor in the albedo change from having a huge area covered in white for a while and then revised just because of that?
Yeah, definitely. And that's the thing with these long-range outlooks. I mean, El Nino's the one variable that we can predict at least 6 to 12 months in the future, so we can base our outlooks on that. But there's so many different variables. Yeah, we also look at like Siberian snow cover in the fall can affect those cold air masses, where they develop, how strong they get. Any snow in Canada or the northern U.S., that albedo difference, that's going to play into it. So if the northern plains don't get any snow in December, yeah, it's going to be, the air will not be as cold reaching us due to that. So there's so many different factors to look at and infinite variables really out there. So good question.
So, on my phone, the first folder that I have is my weather folder, and
Excellent.
And again, there's some great apps available. The National Weather Service has one, the Storm Radar, another. So there's some great apps out there to put on your phone and keep on top of what's going on.
Yeah, we have mobile.weather.gov too. You can add that on your phones. That's a good one.
So, all right. Well, again, many thanks. And next week our program is going to be Black Holes on Black Friday. So hope to see you there or see you on the live stream. And have a safe, and if you're traveling anywhere, have a safe travels for Thanksgiving, and look forward to having you back here at Kopernik soon. Thanks.